Hello everyone, welcome. I'm Mohammed Sufyan, and this is my project tutorial of CS663, and the project is SkyScan. It is a simple, fast approach to aerial object detection. Think drones and satellites spotting tiny things in huge images. Cars in a parking lot, ships near a harbor, people in a crowd. Today I'll jump between a few slides for context and our live tutorial website to show how it actually works. And this is the homepage. Skyscan keeps the speed of a YOLO, which is a popular fast detector. While doing better on tiny, crowded, or rotated objects, we do two practical things. The two are tiling and NMS. We'll get back to the NMS part. And as for the tiling, it is a big aerial photo is cut into overlapping tiles, so tiny objects don't shrink away. And as for the NMS, that's non-maximum suppression. In normal words, when several boxes claim the same object, we keep the best one and drop the rest, so we don't double count. And the next is the datasets and metrics. To stay legit, we use public benchmarks, that is Dota, Wistron, and XView. And let's get back to Dota. Labels are oriented boxes. That means they rotate. The evaluation uses polygon IOU, which measures overlap of the rotated shapes. Here the images are huge, so tiling is normal. And as for the Wiz drones are nothing but they are crowded scenes from drones. Its main score is Coco AP. So in translation, we could say that we average accuracy across easy and strict overlaps. So good boxes, not just rough guesses that matter. And as for the X-View, are satellite scenes with many classes. Classic MAP is often reported. Objects can be only a few pixels, so tiling or light super resolution helps. When we show numbers, we always say data set, metric, input size, and hardware. That's how you compare models fairly. And the next is the architecture. Our recipe keeps it practical. The backbone is a compact CNN, YOLO style for speed, and the neck will be an FPN to blend features across scales, small to large. And the head will be a tiny transformer head, just a couple of lightweight layers to add local contexts so overlapping objects are separated better. And the next is boxes. They are axis aligned by default. We can switch to rotated boxes uh, that they go by, like so they can be CX, CY, W, H, and 0. This can be for the Dota and XView. And the big images. And the big images, they have the following flow. They go from tile to infer, then merge, then finally to oriented NMS. The point here is the balance. YOLO gives speed. The small transformer head gives just enough context for tiny and rotated stuffs without making the model heavy. And the next is the performance. Comparisons can be misleading, so here's our rule. Same dataset, same input size styling, same hardware. For that, we will report the AP, which is the accuracy, and FPS, which is the speed. Here we go by the rule of the thumb. The bigger the input means the higher the AP and the lower the FPS. And the smaller model or INTA quantization means higher FPS, small drop in AP. YOLO baseline is usually the fastest, and also the SkyScan aims to sit near YOLO speed while improving tiny, crowded, rotated cases. Deformable DETR has more context but is typically slower. Numbers on this chart are placeholder. We'll fill them in after experiments, but these trade-offs are what you can expect. And what are the challenges? The real world challenges. So, three practical headaches when it comes to aerial object detection. They can be tiny objects. Cars can be 8 to 12 pixel across. So tiling helps in this matter. And also the occlusion. Objects hide each other, so the model can double count or miss them. Extra context from the transformer head helps. And low light or blur. Confidence drops. You can add modest super resolution or use slightly larger input files. On small drones, we also care about compute and power. That's why we stay with a light backbone and reasonable input sizes. The pipeline on the right shows the whole thing, uh, from tile to infer, then merge, and then finally to NMS, which is clean and simple. And the next is vision language models and the future directions. Open vocabulary detection is one. You can type a class name even if it wasn't in your training list, and the model tries to find it. Systems like Grounding Dino, OwlVIT, and Glib connect text and images. For drones, the trick is to keep it light. You can distill a big model into a smaller detector and cache text embeddings, so you still get fast inference. And before we wrap, we also have a tiny quiz uh, to check the key ideas. What data set uses oriented boxes? What does COCO AP mean? Which model enabled threats prompted direction? And that's it. Hit grade and you get instant feedback. If you teach this topic, the quiz makes a great warm up. And finally, that Skyscan. Fast like YOLO, it hits smarter on tiny rotated stuff, and evaluating in a way that's actually fair. Thanks for watching. If you try it on your own images, tell me what works and what was, and I would love to hear a result out. Thank you.